For today's Journal Club, I'm delighted to be joined by Dr. Arnaud Reignier. Arnaud is a clinical embryologist at the ART Centre of the University Hospital of Nantes in France. He's also a member of the UMR 1064 research team in the Pluripotency and Embryo Development Group. His main fields of interest are embryology, time-lapse, pluripotency, and pre-implantation physiology. Today's Journal Club is the first published systematic review and meta-analysis of blastocele collapse prior to blastocyst vitrification. This study comes from the University Hospital of Nantes in France and will appear in print in Human Fertility later this year. So it's with great pleasure that I would like to hand over to our Journal Club presenter, Dr. Reignier, who's the second author of this article, to present his work.
Yes, thank you, Stephen. So, hello everyone, and thank you for the opportunity to speak today. And we are going to speak and debate, I hope, about vitrification and especially about artificial shrinkage or collapse through a review of the literature and a meta-analysis. So just for your information, Cooper Surgical retained me just to give this presentation, but I have no other relationship with Cooper Surgical and no other relationships with other companies or decision-making authorities. So as you know, vitrification is used in almost all laboratories around the world, and it is now the gold standard for blastocyst cryopreservation. The techniques improved a lot over the last decade, and it is now clear that vitrification gives much more better results than slow freezing in terms of survival, but also in terms of clinical pregnancy rates. As you can see on this nice graph from meta-analysis by Arnaud Reignier and colleagues, vitrification improved a lot the pregnancy rates compared to slow freezing. Nevertheless, vitrification is a very time-consuming technique, as you have to freeze embryos one by one, and it's a difficult technique. So laboratory staff has to be really well trained and perform a lot of vitrification procedures before being confident with the technique. Vitrification is a critical step and standardization is mandatory among the staff in order to have good results. We can also add some extra handlings like assisted hatching or artificial shrinkage or collapse. So those extra handlings were developed in order to maximize the chance of having a living expanded blastocyst after stirring. And you can see on this picture some of them. So you have the assisted hatching when you only perform a laser pulse on the zona pellucida without touching the trophectoderm cells. You can go through the whole blastocyst with a needle. You can perform a laser pulse in the zona pellucida, but also between two cells from the trophectoderm, but far away from the inner cell mass. You can perform blastocell aspiration thanks to a needle and micropipetting. So all those procedures are made to optimize the cryoprotectants penetrations and to eliminate ice formation, which can damage the cellular structures. The blastocell is theoretically an issue for the vitrification process with a risk of ice formation. And this is why artificial shrinkage aims in reducing the volume of this cavity in order to reduce the ice formation. So the two most commonly used techniques for collapse are laser pulse or the mechanical bridge performed with a microneedle. The advantage of laser is that it is quite easy to perform and quite fast, but the initial financial investment is quite important. Blastocell puncture is also relatively easy for people used to practice ICSI, but it is a little bit more time consuming. So the hardest things with these two techniques is to be able to integrate them in the laboratory workflow, as vitrification is often performed while other people are doing the ICSI, for example, or the embryo biopsy. So what do we know about artificial shrinkage before vitrification? Some studies are already available, but they concerned a limited number of patients or embryos. They were quite heterogeneous in terms of design, procedures used for the shrinkage, and the studied outcomes were different. So it was still quite difficult to draw a conclusion from these studies, and that is why we wanted to perform a systematic review of the literature and a meta-analysis to summarize the data and provide evidence. So we performed a systematic research on PubMed with those 4 words, so blastocyst, collapse, vitrification, and artificial shrinkage. And we included other randomized cohort and case control studies comparing frozen solid blastocyst transfer cycle outcome according to the use of collapse before vitrification in humans. So we made the choice not to study animal studies. In order to be exhaustive, the study selection and data extraction was performed by 2 independent operators, so Juliette Boyard and myself. So the research gave 85 results, and after reading the titles, 62 studies were excluded. 7 more after reading the abstract, and at the end, only 8 studies were selected for the analysis. So, as you can see on this picture, some of the studies are quite old now. They were performed before 2010. And you know that the vitrification process improved a lot. They were heterogeneous in the design with some prospective and retrospective analysis. The number of participants and embryos ranged from a small to a large cohort size. The technique used for the blastocyst collapse was different between the studies. Some of them used laser and others mechanical collapse. Some studies included day 5, but also day 6 blastocysts, and the outcomes were different between the studies. So now we can have a look on the results. And so the study groups, so the group with collapse is in blue, and the control group, so without collapse, is in red. And you can see on this graph that for survival rates, you seem to have better results with collapse in much part of the studies. And at the end, when you perform the meta-analysis, you can see that the odd ratio for collapse is at 5.04. That makes collapse better for survival rates. when we look at the implantation rates between collapse group and untreated group, you can see that in more of the studies, it seems to have better results with collapse. But at the end, when you perform meta-analysis, you can see that it was not statistically different. So regarding the pregnancy rates, only 7 studies studied this outcome, and it seems that collapse increased the pregnancy rates. What we all want to know is if performing collapse increase live birth rates, but only 3 studies reported live birth rates. And at the end, we were not able to show a difference between the 2 groups on the meta-analysis. So what have we learned with this meta-analysis? So artificial shrinkage or collapse before vitrification makes better results for survival rates and clinical pregnancy rates, but we were not able to conclude about implantation rates and live birth rates. When you perform a meta-analysis, you have to study all the bias that you can identify in other studies. So here you have all the studies, the bias that we normally study in a meta-analysis. And then you have colors. For the green, you don't have any bias for the study. And red, you have a bias. And when we were not able to answer the question because it was not clearly written in the study, we put a question mark. And so as many studies were retrospective studies, those reports suffered from selection and allocation bias, but none of them suffered from reporting bias. So as all meta-analysis, our study have some limitations. So when you perform a meta-analysis, you don't have to forget that the level of your meta-analysis depends on the level of each study. And we studied mostly cohort or case control studies. Moreover, vitrification protocols improved a lot through the years. And so it is quite hard to interpret all the studies. For example, for the oldest one, it was a time when people made their own medium. And so it is really not what we do today. They use different collapse methods. And now it is quite clear that laser pulse gives better results than mechanical collapse. It is now known that we have to evaluate live birth rates when you perform a study, and only 3 of them studied it. And blastocyst survival is quite difficult to assess without full expansion. And in some of the papers, blastocyst survival was only assessed regarding the degree of dead cells inside the embryo. And still, we have only 8 studies included in this meta-analysis. So what would we need to have the answer about live birth rates? We need large clinical trials with appropriate design and large numbers. We need to standardize the collapse protocols. So I think that the laser pulse is mandatory. And we have to standardize the way people assess survival rates. So I want to thank you for your attention, and I would like to thank all my team, so Juliette Boyard, who performed the analysis with me, and all the members of the IVF Center of Nantes. Thank you. So,
Thank you very much for that insightful and interesting presentation, Dr. Reignier. And I'd like to just bring to your attention that we're now joined by my colleague, Dr. David Morel, who will be part of the Q&A panel. And it'll just be nice to have just another point of view on some of these questions. So we've got some interesting questions indeed that are coming through, particularly the first one. Arnaud, the first one is, what is the role of blastocele function in embryo development?
Okay, so...
Or what is the role of the blastocele fluid, sorry,
yeah.
and what is its function in embryo development?
It is still quite debated. For example, in the mouse, we think that the pressure that the blastocele do on the cells can help the cells to differentiate between drop ectoderm or innocent mass. In the blastocele fluid, we have also some DNA and things that are secreted and that we don't really understand now. So some people think that the fluid is needed to have a good quality embryo and development, but it seems that you have the same results when you put it away. So I guess it is not so important.
And Dave, do you have any view on this?
Just really to re-emphasize what Arnaud just said, I think that the blastocele fluid is there for a reason, and we know from less complicated animals that it's involved in gastrulation and separating cell layers, and you would assume that it plays some role. I think, as Arnaud has said, that the importance of it appears to be structural, and of course by collapsing during vitrification, we make an assumption that the embryo will re-expand at some point, that whatever function it is there for is recovered. And I think that's an important part, obviously, of post-warming assessment.
Cool. Another question, which is about technique. When placed into vitrification medium, blastocysts rise to the surface of the medium because of the high osmolality of the vitrification medium. Is this sufficient for the vitrification process, or is it recommended to place the blastocysts to the bottom of the droplet? And can pipetting at this stage be harmful to the blastocyst?
Normally, when you put your blastocyst in your vitrification solution, you have to take the less medium with the pipetting. And normally, if you do this and then you still pipette in the droplet, it shouldn't go at the top of the droplets. But I think it is better to keep it at the bottom.
And is pipetting at all harmful at this stage, Dave, do you think?
Pipetting can be harmful at any stage, I would suggest. It is more about how you do the pipetting. So, of course, depending on the expansion of the blastocyst, you might have to alter the size of the pipette you're using. Indeed, if it was zona-free, you might take a bit more care. But it's really about sensible precautions. You choose a pipette size, and the vigorous or less vigorous pipetting, depending on the type of material you're pipetting. And during vitrification and using blastocysts is no different. You tailor it to the material you're working with.
Yeah. And another methodological query here. Can exposure to light be harmful during vitrification? So I think this is in addition to when you're pipetting.
For all the procedures, it is recommended not to expose your embryos to too much light, but normally when you vitrify, you take your dish and put it on the light only when you have to pipette. I think it is important to keep it away from the light when you are waiting. And it is so small time that I don't think it can be bad for the embryo.
And you can always use filters if you're worried.
Yeah.
And from the studies that you've looked at, which method do you think is best for blastocele collapse, the artificial shrinkage?
So I really think that laser pulse is the most efficient technique, and that it is not damaging embryo. In some studies comparing the two techniques, they had really better results with laser pulse than with mechanism.
And in fact, this might explain one of the results, one of the studies included in your review. Other than the low number of patients and blastocysts, can you explain the dramatic decrease in survival reported by van der Zwamen et al. Following blastocele collapse?
So first of all, it was quite a old study, and I think that the vitrification process was not as controlled as we do today. And I think that is the reason, and they used a whole technique, and that's why it is quite difficult to interpret results from all those studies, because it is not what we do today, and things change a lot.
True. And then there's a couple of questions really that are related. I'll just read them both. So the first is, did any of the articles in your systematic review include patients having trophectoderm biopsy prior to blastocyst vitrification? And is there any evidence for an impact of that upon the survival? And the related question is, do we need to wait until re-expansion of a collapsed blastocyst before vitrification if it's not being treated using a artificial shrinkage?
So we decided not to include biopsy in our meta-analysis because it is more than collapse or shrinkage. So we really wanted to focus on it. But still, in 2018, there was a nice study from Arnaud Reignier team about it, and they compared a control group without any procedure with a group with artificial shrinkage performed with a laser and biopsied embryos, and it showed that both biopsied embryos and collapsed embryos had the same survival rates, and it was better than the ones who did not have any procedure. And I think that when you perform collapse or embryo biopsy, it is important to vitrify quite quickly after the procedure, for not the blastocyst to re-expand to benefit from the collapse you just performed. So normally we say you have to vitrify within the 30 minutes after your collapse or biopsy.
Okay. And that brings me to a related question, which is, in the 2 years since you concluded your systematic review, have there been sufficient further randomized controlled trials of blastocele collapse to challenge your study findings?
The only study I know is the one I've just talked about from Arnaud Reignier team, and I couldn't find anything else since.
Okay. I'm going to throw this one your way, Dave. Nice easy one for you. Should we reduce the equilibrating time when vitrifying collapsed blastocysts?
Okay, that's a common question, Steve, as you know. I think the quick answer is yes, you probably should. The main difference is, of course, that when you're vitrifying fully expanded blastocysts, that you need the equilibration within the blastocele cavity as well. So all of that fluid needs to be fully equilibrated, and that would typically take longer. So we know, for example, that if you typically equilibrate a fully expanded blastocyst for 12 to 15 minutes, one that is fully collapsed might only take 5 minutes or so.
Okay. I suppose, again, a common problem is why do some embryos stop developing after vitrification? In fact, we had a couple of questions related to oocytes in this respect as well, in terms of have you experienced, for example, that oocytes tend to have lower survival rates compared to blastocysts? And also with oocytes, if despite initial survival post-warming, warmed oocytes tend to degenerate immediately after ICSI is performed compared to fresh oocytes. Do you have any experience of that and any explanation for that?
So the oocyte is a cell full of water, full of fluid. So it is why it is much more difficult to vitrify oocytes than embryos. And when we began to vitrify and so oocytes, we had the same issue with oocytes which were good looking when they were just thawed, and then after the ICSI, it was all dead. And we made a lot of work on the thawing phase. I think that many people focus a lot about vitrification, but not that much about the thawing procedure, which is maybe more important than the vitrification process. Yeah. And so we really have to standardize all the procedure to be sure that everybody does the same. And normally for teams, we practice a lot of egg freezing. I think about the Italians, they have the same results with frozen oocytes and fresh oocytes.
Yeah, they've got an awful lot of good experience. So according to the time of transfer, it's sometimes not possible to see full re-expansion of the blastocyst on warming. So is the beginning of blastocyst re-expansion a sufficient sign of blastocyst survival? I'd have said viability, but the question is about survival.
So when it is not fully re-expanded, you can say that it is alive, but you don't know if it's really going to continue its development. And I think it is really important to be able to evaluate the full expansion. And there are some papers about it that show that the speed of re-expansion is linked to the chance of giving pregnancy. I don't know if you waited maybe 2 hours and it is still not re-expanded, you will know that you won't have good chances for giving pregnancy.
Okay, well, I think we'll probably come to the last question now, but it's an interesting one. So I'll put this to both of you. Maybe you first, Dave. Is it recommended to collapse blastocysts that are beginning to hatch or herniating or indeed have fully hatched?
That is a good question. It's certainly technically fairly easy to do that. I can't say I've tried it with a laser, but with a ICSI pipette, it's easy to draw the herniated part of the trophectoderm back into the zona if you collapse by aspirating the fluid in. And with zona free, again, the same applies. It's relatively easy to use a laser shot. Probably preferable actually, because then you're not holding the zona free blastocyst on a holding pipette, which might stress the cells. So technically it's doable, and I think you would probably, I don't know for sure, but I suspect you'd find similar results, that whether it was partially herniating or zona free, you would still see improvements by artificially collapsing.
Yeah. And Arnaud, have you got any opinion on this?
Yeah, I think that it is quite similar to embryo that you do biopsy, because when you perform biopsy, it is already hatching most of the time, and it works really well. So I don't think that it is a bad thing to collapse the hatching blastocyst.
Perfect. Okay, well, sadly, we've reached the end of the Q&A session. So I'd like to thank Dr. Reignier, our panel, Dave, and those of you attending this webinar for all of the interesting topics that you raised. And finally, a reminder that next week our program will focus on andrology, specifically improving outcomes by targeting the male factor. Full details of the program are available on our website, and please take note that our next webinar will be next Tuesday on June the 2nd. So thank you for attending this journal club, and we hope to see you again soon. In the meantime, please keep safe and stay healthy. Thank you.